Alright viewers, welcome back to Brain Data Science. Well, in today's video we're going to be talking about what? Electrolysis. Okay, without wasting much time, let's go. So now electrolysis here is the chemical decomposition of what? A compound. When we say chemical decomposition, we mean a breakdown of a compound into its component parts. Okay? And into its component parts, into the component or element that form the compound. And you can only do that when such compound is in its what now molten state or what now aqueous what? Aqueous solution. Okay, so now technically I would say electrolysis is the what now? Chemical decomposition of a compound in it melting, that means it's melted to red heat. Melted as melting or what now aqueous solution, or the said compound is what? Dissolved in what? In a solvent. Majorly water. So now, in the solvent, in the solution, into its the composition of the compound, into its what now component part, by the passage of what now electricity, electric current, and the passage of what now electric what current. Okay, a direct what current to be more what precise. So now, a few facts that we need to know about this electrolytic process is that electrolysis is a type of decomposition reaction that will naturally not happen, that will naturally not occur. Such a reaction, we call it what now? It's said to be what? Not spontaneous. So by natural sense, a compound this compound that is going to be split up or broken down by electrolysis will naturally not break down. Okay, guys, it's a process of reversing what the compound into to form the what the component what element that makes up what that compound. We are reversing the process. It's not natural. It doesn't occur spontaneously. It doesn't occur by itself. Okay, so now with that being said, here are some diagrams here to describe the what mechanism of what now electrolysis. Okay, so now, but before we talk about the mechanism of what electrolysis, there is a particular what device that is used to carry out this what electrolytic process. Okay, so now the electrolytic process is usually carried out by a device known as what now? That you can see I have this one. They are all the same. They are both the same. The device also the name of the device is called what now? The electrolytic cell, or you can call it what? Voltameter. Call it electrolytic cell or what? Voltameter. Electrolytic cell or voltameter. Okay, this is what it's called. This entire setup is known as what now? The electrolytic cell or what now? The voltameter. Alright, if you notice, we have some component parts in this what electrolytic cell. Look at now. For the first thing I would like to talk about is that the compound that is in its molten or aqueous solution and that wants to be what broken down or decomposed at this point is known as the what now? The electrolyte. Okay? It's known as the what? Electrolyte. The compound in its molten state is known as the what? Electrolyte. That's what we have here. Of course, that's what we have here. With the compound in its molten or the liquid state. Then in this particular process of water electrolysis, there are conductors through which electricity, the electric current that are going to be passing through the water electrolyte. There are conductors through which the electricity enters and leaves the water now electrolyte. So now we have two of them. We have one on the left and we have one on the right. The one on the right hand side, by my right now, looking at it now, or should I say by the left if I'm facing this particular direction. This particular one on this side, on the right hand side, is known as the cathode. Okay, it's known as the cathode. But mind you, this bar, they are conductors. Okay, they are conductors, and they are generally called electrodes. They're generally what's called what now? Electrodes. Okay, take note of that. They're generally what's called electrodes. While the one that you have two of them, they are different. They perform different function. So now this one, the one on the right is called the what now? The cathode, and the one on the left is called the what? The anode. Okay. So now this cathode is the what? Electrodes through which what? Electric current comes into the what? Electrolyte. While the anode is the electrode through which electric current leaves the what? Electrolyte. Apart from that basic difference, one other thing we need to know is that oxidation. Okay, oxidation. That is the what now? The loss of electron. The loss of electron occurs in the what? Anode. Okay, while reduction, which is the what now? The gain of electron, thereby reducing the what? Oxidation number, reducing the oxidation number of a given atom. That particular process of reduction occurs in the cathode. Okay, so now that's the two major difference between the two electrodes. Okay, so now with that being said, let's move to the what now? The mechanism of what now? Electrolysis. So now in this place now, I already have my setup of my electrolytic cell, or also called the voltmeter. At this particular point, before the electric current is being passed, take note, before the electric current is being passed, this situation now, I have what sodium and what chlorine ion moving within the what situation. In this case, in my own case, in the case I'm trying to use to explain to you now, it's known as what now, the electricity of brine, okay? So now, the electricity of brine basically what is soft dissolved in water. The specific situation I am using to explain on this particular video is what now, sodium chloride. Naturally, sodium chloride in your kitchen will not just split into two and just go back to chlorine and what sodium, okay? That's the natural process. That's what I'm saying, it's not spontaneous. So now we have to use electricity to do that. So now, in this case now, the compound is not in its molten state, rather it is what in its aqueous or solution, that is dissolved in water. Okay? It's dissolved in water. So now, before the electric current is passed through it, take note, the electrons are moving freely. Okay? The electrons are moving within the solution. Okay? They're moving freely within the solution. Okay? So they're moving freely. So as soon as the power source is turned on, the ions start to migrate to what? The electrode that they are attracted to. So now, as soon as the electricity, that is power source, DC source, which is direct current source, is turned on, electricity starts to charges starts to move into the electrolyte via the cathode, which is the one on the left hand side. Okay, via the cathode. Okay, the cathode. So now this cathode now becomes what? It now becomes negatively charged. Okay? Electrons are coming through it. Of course, electrons are coming through it, entering it. It becomes what now? Negatively what? Charged. Okay? It becomes negatively charged. On the other hand, the anode here. On the other hand, we have the anode here. As the currents are coming in, it's just conducting it. The conductors are taking it into the electrolyte. The electrolyte is moving the what? Electricity and taking it out through this other what? Anode. So because this is the area where electron leaves the electrolyte, this one becomes what now? This electrode specifically the anode, becomes what now? Positively charged. Okay? So now, looking at it, positively charged, negatively charged. So now going by the basics of what now? Electrostatics, that's what static electricity in physics. If you look at that now, like charges they repel each other, while unlike charges they do what now? They attract. So now take note of that basic fact. So now the metal, as usual from basic chemistry, metals are what? Positively charged. They are positively charged ions, as you can see them in this place. So as soon as the electric source is on, electrons start moving into the what? Electrolyte. As electrons are moving, this electrode becomes negatively charged. So as it's becoming negatively charged, the metals what? Are attracted to negatively charged electrodes. So they migrate towards that particular what? Situation. They migrate towards the what? Negatively charged what? Electrode. Okay? They migrate towards the negatively charged electrode and they cleave to it. Okay? They cleave to it. But I'll tell you what happens as soon as they cleave to it. Okay, the same thing goes with the what? Positively charged what? Electrode, which is the what? Anode. The negative ions, they what? Move close. They move towards the what now? The negatively charged what? Electrode. Okay? Since they move towards the negatively charged electrode, they cleave to it. So now let's see what happens in each of the what? Electrode. So now in the cathode, because electrons are coming and we have the ions, remember the main purpose of electrolysis is to break down the compound, separate them into their component element that form the what now? Separate into the component element that form the compound. Okay? So now we are it's not a normal chemical reaction, like we are reversing it, we are reversing the process back. So now, for a normal chemical reaction, there's something called ionization. That's formation of ions. Before formation of ions, in order to form electrophilic compound or ionic compound, in normal chemical reaction, a non-metal forms ion by the by the gaining of what now? Electrons. The white metals, they form ion, which is ionization, by the loss of electrons. Okay. So now, I don't want to go into details of that. We have a video concerning we have a video talking about what ionization process, but that's not what we're talking about now. So now, what we are doing here is actually the reverse of that ionization process that would naturally occur in a normal spontaneous reaction. We are reversing it back. In this case now, metals are not going to be losing electrons because we are trying to turn a metallic ion back to its atomic form. So now, instead of metals to lose electron now, they will now be what? Gaining. As they are gaining, since the ions are already positively charged, since they are gaining, the oxidation number, which is the valency, or the oxidation number becomes reduced. In other words, reduction happening in the what? Cathode. Then the same go for the what? Non-metals. Non-metals, by normal chemical reaction, they ionize, they form ion by the what? Gain of electrons. But in this case, they are already their ionic form. We are turning them back to the atomic form. So instead of it to gain electron, it will now be losing electron. Remember, this cathode now is where electron leaves the what? Electrode. So as soon as they take their ions towards that particular electrode and cleave to it, they lose the electrons, and they come back to the normal atomic form and join back to each other and form a molecule. So now look at what happens now. So now by the time the sodium ion gets to the cathode, which is the negatively charged cathode, it goes there and it receives the electron. Remember, the cathode is negatively charged because electrons are coming through it. So electrons are negatively charged. So now it moves towards it. It gains an electron. It turns back to the what? Atomic form. Okay? Look at the reaction. Look at the ionization what? Form. For a normal ionization reaction, metals. We're writing the normal ionization equation for metals is not like this. But because of electrolysis, it's actually taking the opposite form. Okay? So now the metallic ion gains the electrons and form the what? Normal what? Metal. Look at it now. It comes back to it. You discover that in this case it was having a charge, but in this case it's what? The charge has moved from what now? +1 back to what? 0. Look at what it is now. +1, it has moved back to what? 0. That means the oxidation state has what now? Reduced from +1 to what? 0. That's why we say reduction happens in the what now? In the what? Cathode. Okay? So I form the metallic what? From the metallic atom of what? Sodium. They are not deposited at the what now? Cathode. That's that for the cathode. Then for the anode, because this non-metal is a gas, this is what happens. As soon as the non-metals, they move in pairs of what now? 2 ions, they cleave to it, they go back to, and they cleave to it. By the time they cleave to it, remember, electrons are leaving through this what? Anode. So as soon as they cleave to it with their negative ion, electrons are taken away from them, that means they lose electron. And their number, and their oxidation number, that is -1, quickly move to what now? 0. They now form the molecular. No, in this case of chlorine now, is what? It's molecular form. So it now form chlorine gas. It's not coming out as a what? As a gas. Showing that what now is losing 2 electrons. This is not how to write ionization equation for a normal reaction, that a normal non-metal that is gaining electron. This is the opposite. Okay? So now, chlorine molecule, showing that it's what I'm losing what? 2 electrons. It's losing what? 2 electrons. It's not behaving as a metal. So now, because the oxidation state is -1, it now turns to 0 here, neutral, which is neutral molecule. It's not said that what now? Oxidation, that's oxidation is the loss of electron. Now said that the oxidation happens at the what? Anode, because the chlorine now loses its electron as the electrons are moving out of the what? Electrolyte. So now as they form their atomic form, they cleave back to form the molecule, and they escape as what now? Gas. They escape as what? Gas. They escape as what? Gas, and they are collected somehow. They are collected via the what? Maybe a gas jar, okay? In the laboratory, or yes, in the laboratory, or maybe more standard solution. So now this is how it works. So now a short form for you to remember which happens, which particular what reaction occurs on the anode, on which anode. This is a simple mnemonic to know that. So now we have CRAO here now. Cathode reduction, which is the what? Where reduction is happening. Cathode reduction. Cathode is the what? Part where the electrode where reduction happens. RO, now we have what? Anode oxidation, which is the part where what oxidation occurs, okay? Which is the part where what oxidation occurs. So now one more point I would like you to note before we close the chapter for this video is that what now? For every electrolytic cell of voltameter, the cathode will always be on the what? Right hand side. Like by looking at it, it's always on the right hand side. Why the anode will always be like what now? Left hand side. And remember, cathode is where reduction happens, which is the gain of electron to reduce the oxidation state, and what anode is where the what oxidation occur. That means loss of electron. That means loss of electron, thereby what now increasing the what oxidation what state. Okay, it is the oxidation state. So now the cathode is the negatively charged electrode because that's where electrons are coming in, and that's why reduction is also happening there. Okay, now, so now anode is a positively charged electrode because that's where electron is leaving, and also but this electron is leaving there, reduction oxidation will now what occur there. Okay, that's loss of electrons. Okay, that's a very tricky way to know what is happening there. So now these little thing I said here now is actually we're trying to describe the mechanism of what now? Electrolysis. So now one more time, electrolysis is simply what now? The breakdown of what now? A compound that is in its either molten form or what now? Aqueous solution. Thereby reversing to form their component form the component element that makes up what the compound by the passage of what now? Electric current. Specifically DC current, that's direct current. Alternating current does not occur with it because alternating current moves in both directions, moves in cycles. That means move back and forth in cycles. So that back and forth movement will not allow it to what? Allow the process to be what? To be optimal. Okay? Not allow it to be what? Optimal. Okay? So the best type of electricity, best kind of electricity that is being used is what now? Direct current, because direct current travels in one direction. So now I think this is it for the whole video, and I hope you gain value from this. And don't forget to hit the like and subscribe button. See you in the next one. Have a nice, wonderful day.